Welcome everybody. This is my first meeting here as officially as the director of the Brain Initiative. It's really quite a privilege to be here. I'm delighted to take on this role. Again, just to welcome our three new members, Randy, Koff, and Samir. Really delighted to have you with us. I'm looking forward to working with you and really appreciate the diversity of expertise you bring from molecular biology to genetics and psychiatry and bioengineering to functional neurosurgery. I think your wisdom and experience will be very much appreciated as we dig into the issues of the day and beyond. I'd like to give a thanks to Christoph Schreiner, who will be leaving us after this meeting. Christoph is our colleague from UCSF in otolaryngology and head and neck surgery. And his research has been focusing on the central auditory system of the mammalian brain. Christoph, thank you again for all the wisdom and time and expertise you have imparted. You've certainly helped us make this a better initiative because of your efforts. So thank you again. And I have to give a special thanks to Josh and Walter, our fearless leaders. They're still with us, but they're no longer chairing MCWG. They've handed over the keys to me. I really thank them for their support and trust in this endeavor, and also for being available for their continuing support and wisdom as we move ahead in this next phase of Brain. So thanks again to Walter and Josh. I think Walter is on the line here somewhere. Josh is probably taking a much needed vacation. So. Okay, so since we last met, I was involved in this transition. I think my official day at NIH was 2 days after our last meeting here. The transition team has now transitioned into what we call the Office of the Brain Director. I've come to learn that every unit at NIH needs some acronym, so ours is OBD. We've kept and grown the team since then. Andrew Beckel-Mitchener is now the acting deputy director for Brain, and we continue to have Greg Farb and Ned Talley giving really great input as senior advisors within OBD. Michelle Pearson has been named chief of staff, and we've been joined in the administrative team by Nee Floyd and Shauna Back. I think some of you may wind up interacting with them as we move forward, as we seek advice from you, and as we start setting up and holding workshops. And finally, Ryan Richardson has just joined us this week. He's a AAAS fellow. Really great to have him here. Great to have a trainee with me again. And we're looking forward to having him dig in and learning what's going on within the NIH and contributing to this really exciting endeavor. Okay, so big thanks to the 100+ people who have been working on Brain from across the 10 ICs and beyond. I can't thank them enough for all their really great work, especially during these difficult times, juggling the extra workload from the pandemic, as well as for many of these folks, family issues with everybody staying at home. So again, I hope you all can join me in appreciating all that they do for us every day, especially during these very difficult times. So since we last met, there's been a slight reorganization of the teams. As many of you may know, or probably do know, the Brain projects, the extramurally funded projects, are managed by a set of scientific project teams. This is where the ideas come from for the concepts, for conceiving and writing the funding opportunity announcements, for handling the applications coming in. Then they go to review. Then there's secondary review, and actually managing the projects. So we have these various teams. Prior to May, we had a team called Team D, which covered training and diversity. Because of some staffing changes, we had an opportunity to step up an independent team focused only on dissemination, and I thought that I believe was announced last May. And we have co-leads Carrie Ashmont and Meg Grab. We now have a new, the training team was then expanded to include issues involving diversity, and not just in training, but across the entire workforce within Brain. And Dr. Jay Churchill was the previous co-lead for the training team, and he's been just joined by Michelle Jones-London, who many of you may know through her efforts in training and promoting diversity, equity, and inclusion through her work at NINDS. So we have these two new teams now, and I think we've really set ourselves, positioned ourselves well to address the challenges that BRAIN faces as we develop and need to disseminate the tools coming out of BRAIN and other technology areas. This team will be moving that along, and there's the stepping up of diversity to the team level really ensures that we can keep these issues front and center to ensure that we are really developing not only the best workforce we can for the future, but to ensure that we're doing the best science that can be democratized for all of society. So we're very excited to work with all the teams, of course, and particularly excited that we have some new faces on board with some additional focus on these critical issues. Okay, just a reminder of where we are these days. This is the past and projected budget for BRAIN running through 2026. The total projected budget for the lifetime of BRAIN as it stands now is $5.2 billion. Right now, we're not through the fiscal year 2020 yet, but through 2019, we're about a third of the way through at $1.3 billion. And the budget as it stands now is at around 500 million, which not so coincidentally is what the recommended funding goal was from the BRAIN 2025 report. So this report was in many ways prescient, and I'm happy to say that we have met that goal, and our purpose here is to make sure we make the best use of this much appreciated investment. Okay, so I'm going to hand it over to Sam White. Sam, are you here with us?
That I am.
Okay, are you ready for me to advance?
I am.
Great.
So as I hope a lot of you realized, ooh, these are going way faster than they were supposed to. We had a BRAIN Initiative Investigators meeting this year, despite COVID. We did do it virtually instead with a very fast turnaround that took the effort of villages upon villages of people. But it happened on June 1st and 2nd. It is all still on demand. So you can go to the website, anyone can go to the website that is listed at the bottom of the screen, and you can register for free and you can access all of the different materials. So those materials include keynotes, symposia presentations, presentations from 30 different trainee awardees, presentations from 3 different workshops, 2 on science communication and 1 on neuroethics. And it also includes over 400 posters. And the posters are in kind of different levels of detail. Some of them are more text-based, some of them are traditional posters, like a PDF with the graphs and whatnot. And then some of them actually have audio that is matched to it. So it's as if you're getting the poster spiel, like you were really at a conference. I think one of the things that NIH learned from doing this is that we have the ability to reach far more people in this virtual space. So that is a great silver lining on this pandemic cloud. We ended up having about 3,000 users over the course of the 2 days, and there were over 4,700 people who actually registered for the event and have subsequently followed up to look at different content. And this is stretched all across the world. It's not just been isolated to the United States. So there were 2 different graphs here. We landed on the one about trainees, which is fine. So when we were looking at people who registered and filled out the extended registration that we had previously available, we had almost 550 NIH-funded scientists who filled it out and about 270 NIH-funded trainees. And we are seeing a continued increase in diversity in terms of disciplines that people in the BRAIN community indicate they have experience or practice in. In particular, we're seeing here the NIH trainees showing a huge representation across all areas of biomedical sciences. It's not just about neuroscience, which is really one of the goals and one of the things we've been trying to do with some of the funding opportunities, and is really something that we wanted to achieve with the PI meeting, to let all of these different people with different perspectives, areas of expertise really come together and talk to each other. So John, if you could go forward a slide.
Okay, put on your seatbelt. This may go kind of quick.
Okay, no, this one didn't have animation.
Okay.
So coming from the 2 days, one of the things that we did was we made sure to put up a survey. The survey is still available at the meeting website. So if you do go after you hear this, please fill it out. Please let us know what you think about it. Please let us know what you think about the content that we had. There was overall very positive feedback. There were a couple of pieces where people were thinking, particularly if we're going to be stuck in this virtual space for a minute, that there could have been more instances where small groups could really get together and talk, not just a typed chat, if you will. And that is great. It was a little early in the process for us to have coordinated that for such a large scale, but is certainly something that I think we can apply to a lot of different scientific workshops and meetings moving forward, and certainly can consider for 2021. There were notes about the different scientific topics that were covered. Again, these topics are coming from the discussions of a program committee that helps create the agenda for the meeting. These are federal and non-federal people. We always have representation from the multi-council working group. This past couple of years, Christoph has provided that support to us. But we also get it from the community. We get it from the feedback from the meeting before, and we also get it from the submissions that people put in for symposia conversations. That said, also worth noting and we're thinking about as we move forward in the calendar year. And then I think something that's quite topical at the moment is that people really call to us to make sure we have representation. We want to see more minority voices in science, more perspectives from everyone across the spectrum at meetings like this. We need to be careful about who we're highlighting as our speakers, and people are really motivated and mobilized to make sure that this is something that we see in the coming years for the meeting. We did also ask people, okay, so what else do you need at this point? Given everything that's going on, given the state of the science, where are you still looking for support? And so the 3 options here kind of rose to the top. There were certainly a few more, but people are still really interested in having an opportunity to work together on best practice and troubleshooting when it comes to data science and informatics. People are still looking for that support when it comes to dissemination and commercialization. So I think John's point earlier about how we've kind of revised the programmatic teams in NIH and how we approach the BRAIN initiative is very timely for that. But then people are also looking, despite being stuck and away from each other, for more training opportunities. As BRAIN is coming up with these new tools, these new technologies, these new theories, these new processes, where can they go to access them? Where can they go to get trained so they really can implement them? And we can see that kind of broader spread, even beyond just when you get to go to a conference and hear someone talk about the tool. So with that, I do want to take 2 seconds to see if anyone on the multi-council working group has any other particular insights about the PI meeting from your experience, if you were able to join us in June. But if not, there is, of course, the ongoing feedback survey that we have available. The link is displayed here. But like I said, if you go to the on-demand content, it's accessible through that platform as well.
While working group members are pondering some comments, I just want to take a moment to really give a shout out to Sam and team. This could not have happened without them, and they did a great job in moving this to a virtual meeting on a moment's notice. Things were very, very fluid back in March, and we had to make a hard decision to move this meeting to a virtual one. And I think they made it not just the best we could do, but it really turned out to be, from my point of view, a terrific event. I'd also like to give thanks to Eve Martyr. Eve gave one of 4 terrific keynote talks, and I know that the format was difficult being online, but it really worked out great. So Eve, thank you so much for taking the time to do this.
I don't see any hands raised, so maybe we should go on and people can still put their comments in the chat and we will get them to Sam.
Okay, shall I continue?
Yep.
Okay, and we have a few minutes left. I want to leave some time for discussion. This is the fun part, I think, for me at least, of the presentation, where we get to highlight a few of the studies that have just been published from brain-funded investigators over the last several months. I've only chosen 4 highlights to keep things brief, so please bear in mind this is deliberately a very sparse sampling. There's a lot of terrific science out there that's being done. Hopefully you'll be reading about it as you go through the journals. I just wanted to touch on 4 projects that hit on different areas of the Brain Initiative, projects that are being funded. Here's one from a great collaboration between Dr. William Yang at UCLA together with Hongwei Dong, who's just moved to UCLA from USC, and Honghui Zhang and her group up at the Allen Institute. And this is a technique called MORPH, a mononucleotide repeat frame shift mice. This is exciting. It's a modern version of the Golgi stain that Ramon y Cajal used over 100 years ago to characterize the multitude of neurons in the nervous system, really gave rise to the neuron doctrine. So as I'm sure all of you know, the Golgi stain works so well for this purpose because it didn't label every cell or its processes in the tissue. It only, because it was inefficient, it only labeled a few, and the sparse labeling allowed Ramon y Cajal to not only identify individual cells, but also their very intricate processes that they elaborated. So what Dr. Yang and his team has done is they've used some molecular trickery to enable this kind of approach to be used in the modern genetic tools that are coming out of projects like the Brain Initiative Cell Census project. And here he's put a string of nucleotides, a mononucleotide repeat, a string of 22 C's or G's that introduce a frame shift mutation within these reporter genes that are normally activated by things like reorganization or TTA that are expressed under cell type specific control. And it turns out when the cell sees these mononucleotide repeats during DNA replication or repair, it tends to make errors. So stochastically, a base might be removed and that puts everything back in frame. So he's very carefully designed this. So the percentage of these stochastic events is about 1 to 5%, typically around 3%. And he's made various flavors of these reporters. In the spirit of a picture being worth 1,000 words, here's a video that I think is worth at least 10,000. And so here we're seeing one of these such mice, and I'll just kind of let this video play and we can just all enjoy the view as we fly through this cleared thick section of a mouse brain expressing one of these morph reporters. Hippocampus is just going by underneath. Here we are on the cortex, and we can see the intricate processes of individual cells because of the sparse labeling. Okay, so while we're enjoying that, here's some other examples you can see in the cortex that allows the isolation and identification of the fine processes and the ability to trace and quantify the nature of those elaborations. What's really quite brilliant here as well is that they've designed one of these reporters as a membrane-bound reporter that can be detected by antibody and then can be detected through electron microscopy. Last time we talked about the Connectomics project as a next wave project for the Brain Initiative. And one of the key, I think, challenges will be to connect light microscope level information to EM level, high resolution, nanometer scale resolution maps. And this provides a potential bridge between the meso and nanoscale analyses. So very, very exciting. It's great to see the principles that were established in the previous millennium now modernized with these tools. So we're very excited to see the application from this wonderful collaboration. The next study comes from Dr. Fan Wang at Duke University, who has been studying the circuits involved in sleep and analgesia using very sophisticated genetic tools. And as a study complementary to her work on the sleep circuits, Fan and her colleagues have identified an ensemble of neurons in the central amygdala that actually activate pain suppression. So for me, naively, when I think about analgesia, I'm thinking about, well, something is being turned off, but here there's an activation of a set of inhibitory neurons that are mediating that process. And by using optogenetic techniques combined with genetics, following the identification of cells in the central amygdala, this ensemble of cells that are activated upon exposure to general anesthetics, whether it be isoflurane or ketamine. They're then able to use this technique called CANE, which captures the active neuronal ensembles through CFOS and other trickery using virus delivery. And then they can later go back and reactivate those cells in a different context and see whether those cells, in fact, mediate this analgesic activity. And indeed, when they go back and activate those previously activated cells using this technique, they can show a diminution of pain behavior responses, either in the paw licking assay or in the scratching assay involving this peripheral, this central nerve ligature. So it's really a beautiful discovery that of the cells and in the central amygdala that are giving rise to this pain suppression in response to general anesthetics. And importantly, it now provides a way in to identify exactly who those cells are as a potential therapeutic target for alleviating chronic pain. And this has ramifications not only for pain, but as I'm sure all of you can appreciate, also in the areas of drug addiction. So very exciting work using some beautiful molecular techniques, novel ways of labeling active cells in the pursuit of circuits involved in very important behaviors that face us. Okay, so getting into some human neuroscience, here's a really cool study from Dr. Danny Bassett at Penn in collaboration with colleagues at the Sorbonne, and they're trying to understand what goes on in the brain as researchers train subjects to use brain-machine interfaces or brain-computer interfaces that might be used as neural prosthetics. And one question they had is what happens to the coupling between areas in the brain during this process? And what they found was that the skill acquisition process is associated with a progressive decoupling or functional disconnection of associative areas and a reinforcement of the sensorimotor activity within the areas that they're targeting. So this offers a way to look at what's going on in terms of cortical reorganization during BCR learning. It could have some really good predictive value about who's going to do well or not so well, and it could actually, I think, shape how those regimens might be applied as they test and deploy these technologies on different individuals who, of course, will respond differently to these interfaces. And the last vignette I'll give you comes from Dr. Eddie Cheng from UCSF, who, as I think many of you know, has been a pioneer in understanding the sensorimotor circuits involved in human speech generation, using access to the brain during surgeries for epilepsy and other patients. So using ECOG arrays, they can record from patients as they are speaking whole sentences. And the idea is to develop a brain-machine interface as a neural prosthetic. So for patients that are suffering from stroke or other afflictions that are unable to communicate through speech, the idea is if we can record the activity and decode the activity that underlies that speech generation, we could actually give them the ability to communicate that way through these speech prosthetics. So here in this diagram, they record signals over this part of the cortex while they have the subjects read full sentences. I think they used a total of 250 words. They put this output from these ECOG arrays into this neural network. There's a temporal deconvolution where they look for the pattern and timing of these this activity. It goes through an encoder and a decoder in this recurrent neural network that comes out with an output. And apparently within the framework that they're looking at, it shows a remarkable ability to generate the actual speech and word patterns, and it actually has the ability to handle quite well the encoding and decoding of novel words. So this is a very exciting development. This is surely an area to watch, and clearly one of the highlights of the BRAIN Initiative in terms of taking some very basic information from humans now and turning it into a potential prosthetic for use in patients. Okay, and I think I just want to wrap up a few minutes, the last few minutes talking about COVID. As you know, that COVID has turned our entire world upside down, including among our investigators. There is information here that people can avail themselves of for how to seek help for mitigating the delays and other damages done by COVID. So this is all on the NIH website as well as the BRAIN website. As you know, NIH is leading the charge in finding novel therapeutics, diagnostics, and ultimately, we hope, vaccines that will bring this pandemic under control. Here are two of our heroes, Dr. Francis Collins, director of NIH, and Dr. Tony Fauci, who I'm sure all of you have seen leading the charge as director of NIAID. Many agencies are involved in this. Right now, there have been 2 clinical trials stepped up at the NIH, Active 2 and Active 3, looking at the efficacy of monoclonal antibodies as a therapeutic. Very much going on, really too much for me to get into any detail here. There are several clinical trials being run by NIAID, again, to look at the efficacy of various therapeutics, including remdesivir. And then finally, as I think a very important part of controlling this pandemic, as we were discussing before the meeting started, is the area of diagnostics. So here, the RADx program, the Rapid Acceleration of Diagnostics program, is being led in this case for developing point of care technologies and by NIBIB under the leadership of Dr. Bruce Tromberg. And here there are a number of contracts out there to really accelerate the development of these diagnostic tools that will be critical for delivering point of care technologies out in the field so that people can be tested and get reliable results back quickly. So hopefully we can all get on with our lives. And with that, we are running a little bit over, but if there are questions that from the committee, I'd certainly like to take some time to take them. So thank you very much for your attention.
I would just like to say one thing, and that is those of us who've been giving a lot of talks virtually in the last 6 months, learned that you can actually communicate extremely effectively, but differently than classic meetings. And so I've seen a number of really exciting developments on how 3 or 4 people can work together ahead of time to put together a joint presentation, which works better than almost any seminar I've ever heard. And I think one of the things that you guys might think about for the future is making meetings a mixture of virtual and in person, but also coming up with a really systematic way of encouraging the community to capture the fabulous numbers of presentations that are being given virtually around the world, and somehow or other creating what would be a really effective library of these talks for students, especially in a time when students have less access to FaceTime with people. I think one could create an incredible library, and not just assume that every young person is going to be able to find what they're looking for.
Thank you, Eve. These are great comments. And indeed, this has been an opportunity to revisit how we conduct our science and how we get information out there and seek input from all sectors of the community, especially among the trainees. I mean, as you saw from the numbers that Sam showed about the number of people who actually signed up for the BRAIN investigators meeting, not everybody can travel to the meeting. Not everybody has the resources to do that. So in some ways, this has been a great democratizer, assuming they have internet access. And so we are certainly looking into ways to make this even better. Right now, all the meetings and workshops that we have on our planning docket, they're all being assumed to be virtual until we have the situation under control. It's amazing what you can do that you didn't think you can do until you're forced to do it. So this is just our opportunity to do it better. So those suggestions are really welcome.
I just want to second this. I attended the Galaxy Community Conference and the wonderful Neuro Academy this summer, as well as the brain meeting. And I am not sure that any face-to-face meeting is going to offer the opportunities in terms of inclusiveness and the content that is out there, because it captures the content, as Eve says, and it allows us to create a real-time, very cutting-edge suite of training tools for students. So I'm very excited about what the virtual space is doing. I know we're going to have conversations about diversity, equity, and inclusion, and I think this format perhaps furthers that more so than the face-to-face conferences as we've participated in them before.
But it really requires creating either a website or some tool to allow students to find the right things in the right way. So somebody has to do the equivalent of the Library of Congress, if you will, for these talks that are being given in all sorts of ways and that are being captured probably reasonably effectively. And I just think it would be amazing for, you know, a sophomore in college to be able to find the whole world of neuroscience or the whole world of biology easily, and not have to go through weird little YouTube things.
Yeah, I appreciate both of these comments, Alba and Eve, and as I'm sure that you've seen on your own campuses, you know, transporting an in-person class into a fully online endeavor is not just a matter of putting a bunch of lectures online. It's a different way of going about it, and there are different challenges, but also different opportunities. And I think as we're kind of finding equilibrium, I think now we need to really focus on what the opportunities are.
Jim has his hand raised.
Okay, Jim, before you go, Kristen, I seem to have lost control of my computer. I can't stop sharing. Hopefully you can, otherwise we're kind of in deep trouble. Can you stop sharing? Thank you. Phew.
Thanks, Susan. Yeah, John, I was just wondering, in context of the pandemic, in terms of COVID, certainly the Brain Initiative's remit is not to work on disease-related work, but we all use viral vectors for introduction of transgenes into cells, and they're great insights into providing insights into neuronal functioning. I just wonder if there might be an opportunity to try to get a bit more into infectious manipulation of the brain as a standard manipulator of the CNS, and use that as a way of trying to understand the disease processes, but also just general perturbations of the brain. There might be an opportunity here for R1 funding for these types of viral infections.
Yeah, that's a great point, Jim. We'll certainly take that under consideration. What's really impressed me during this pandemic is the alacrity with which investigators throughout the extramural world have pivoted to apply their considerable creativity to attacking this pandemic. I was involved in one as kind of a minor player. So, it has happened. We certainly have the tools. We certainly have the intellectual horsepower to do that. We will certainly look into how we might be able to more effectively interface more, directly and intentionally into those efforts. But right now, the good news is people have managed to do it and really make, I think, some very important contributions.